one more section here. Let's talk about measures of position. Yes. Measures of position. Well, measures of position, just as the name suggests there, these measurements tell us about where a value is with respect to other values, I guess, is the way we put it. The first one is the z-score. First measure of position is z-score. The z-score, what it measures is, it measures how many standard deviations a value is from the mean. How many standard deviations a value is from the mean. How many standard deviations a value is from the mean. Let me just give you the formula. Here's the formula, the z-score formula. Z for z-score equals, you take the value minus the mean. Does that look familiar? Yeah, should look familiar. You did the last section there. It's the value minus mean, but then I'm going to divide by the standard deviation. That's the z-score formula. That's the formula you should know how to compute. So let's just do a couple. All right, so let's say we've got some data in this distribution. In the distribution, we've already got the mean and the mean standard deviation. The mean is 40. And the standard deviation, 2.5. Number one. Oh, and I was going to mention here, some of you may like notation. If you just like symbols, some of you like words, but if you just like symbols, what would this be? This would be x minus x bar divided by s. So if you like symbols, there you go. And it may be in the book like that too. So, but this means this. It's the value, the x value, it's an s, minus the mean divided by the standard deviation. Okay. So anyway, number one, find the z-score of 45. And we'll write that z45 like that. What is z45? Z-score 45. Well, I take the value minus the mean, which in this case, what's the mean? Gave it to be 40. And divide that by the standard deviation, which is 2.5. What does that work out to be? Well, it's 45 minus 40 is 5, divided by 2.5, that is 2. Okay. What this is, like I said, this means, I mean, a lot of times we're just computing it and not even really thinking about what it means, but I'll give you a question here where we may need to think about what this all means. So here's what this means. This means 45 is 2 standard deviations from the mean. That's what standard deviation. And that makes sense, doesn't it? Because each standard deviation is 2.5. The mean is 40. So if I go from the mean, 40, if I go 1 standard deviation, where does that put me? Well, that puts me at 42.5. If I go another standard deviation, another 2.5, that puts me at 45. So that's all this means. It's 45 is 2 standard deviation steps from the mean. Does it make sense? See what I'm saying? That's what this 2 means. It means it's 1, 2 standard deviations from the mean. Okay? Number 2, find the z-score of is it 30? Yeah, the z-score of 30. Well, the z-score of 30, what would that be? 30 minus 40 divided by 2.5. The value is 30. The mean is still 40, so it's 30 minus 40 divided by 2.5. What does that get you? Well, that gets you negative 10 divided by 2.5, which is negative 4, isn't it? Now, somebody tell me why it's negative. Why does this? It's below the mean. The z-score of 30 is negative 4 because you're below the mean, right? 30 is, we're going backwards. And we're going backwards 4, so that's why it's 4. But the reason it's negative is because it's below the mean. Anytime your value is below the mean, the z-score will be negative. Okay? All right.
We got 40 from the original. Right?
Yeah, the mean is 40, so that part was given.
Would that make that number 23.5?
What? Say that again.
Wouldn't that make that number 23.5?
Which number?
If you went negative 4 from 2.5.
Oh, no, if you go back 2.5 every time. Yeah, you go from 40. Okay, number 3. Just to mention here, find the z-score of 47. 47, sorry. Find the z-score of 47. There we'd have z-score of 47 would be what? Take the value, which is 47, minus the mean, which is still 40, divided by standard deviation, which is still 2.5. With me on that? So we get 7 divided by 2.5, which is 2.8. Which my point on doing that is, yeah, z-scores don't always come out to be nice whole numbers. Z-scores can be decimals. Because that one's just, it's not a full, it's 2 and then almost 3 standard deviations. See what we're saying? So it's not quite 3, it's 2.8. All right? So that's z-score. Now, one type of problem they'll ask you about is one like this for z-score. Let's say Matt made 75 on his history test. Joyce made 60 on her science test. And we're going to know this. The class mean on the history test was, what was it? 68. With a standard deviation of 2.3. While the class mean for the science test was 52 and a standard deviation 1.9. Okay, here's why I'm giving you all this. All right, so Matt and Joyce are trying to compare their scores, apparently, for what we want to do. Of course, Matt was saying he made better than Joyce did. However, Joyce might have a case here because, for a lot of reasons, we don't know how many Matt's was out of. That's really not what we're comparing. I mean, Matt's may have been out of 500, so be no contest. But that's beside the point. With the information given, here's what we want to look at. Who did better, relatively speaking, to the others in the class? Who did better? Relative to the others in the class, in their classes. How could we do this? Well, obviously, what we're going to do is use the z-score. What the z-score does is the z-score is talking about standard deviation, and that kind of standardizes. Another reason why it's called standard deviation is it standardizes data in different groups. A standard deviation 1 here can be compared to a standard deviation of 1 over here. So that's the idea. So the z-score is a good way for such a problem as this. Compare the z-scores. Now, let's think about it. Would I want a z-score that's higher or lower to be better in this case? Well, a z-score that is higher means it's further away from the mean, right? And so thus did better on the test. So I want it further this way from the mean. So I want a higher standard deviation. Okay. But we'll talk about that more. All right, so let's compare the z-score. What is the z-score for Matt on his history test? Well, I take Matt's value, 75, minus what? 68. The mean of the history test divided by the standard deviation, 2.3. With me? 75 minus 68 divided by 2.3. That is 7 divided by 2.3, which is 3.04. The z-score of Joyce, well, that's her value, which is 60, yeah, minus the mean for the science test, 52. Divide that by the standard deviation of the science test, which is 1.9. That's 8 divided by 1.9. That is a little over 4, isn't it? 4.21. So who did better, relatively speaking? Joyce. Joyce did better. Higher standard deviation. Higher z-score, I should say. Yeah, her score was further out, standard deviation-wise, than was Matt's. He was only 3 standard deviations away. Hers was a little over 4 standard deviations away. So here's the mean, and Matt's here, Joyce is here. So that puts her further out, 4.2. Okay?